Hey everyone, welcome to this explainer. Look, if you're tuning in, you probably already know that getting a single container to run on your local laptop, well, that's the easy part, right? But leveling up your day two container operations, moving from a clunky legacy application to a sleek, automated, cloud-native platform is a totally different beast. Today, we're going to walk through the real-world patterns that actually work, drawn directly from the trenches of modern software engineering. So let's just get right into it. We've all felt the pain of a tangled, massive, monolithic application. I mean, the dependencies are super brittle, releases take absolutely forever, and just one tiny minor change can totally break production. You're probably sitting there dreaming of blowing it all up to do a massive Big Bang rewrite. But history tells us those almost always fail. What we really need here is an evolution, not a revolution, and that evolution starts right now. Here's our roadmap for this explainer. We're going to cover 1. Modernizing legacy systems. 2. Breaking down microservices. 3. Automating with CI/CD. 4. Deploying to the cloud. 5. Orchestrating at scale. And finally, 6. Securing the container. All right, kicking things off with Part 1, Modernizing Legacy Systems, Transforming Monoliths into Containers. Now, notice how incredibly logical this progression is. You don't just take a sledgehammer to the monolith on day 1. Step 1 is simply lift and shift. You're aiming strictly for environment parity, packaging the app exactly as it is right now. Then, step 2 is refactor, where you start, gently extracting background jobs or maybe externalizing your configs. And finally, step 3, re-architect. That's where you actually redesign the entire system into cooperating services. So you start with containment first, and then you evolve incrementally. Moving right along to Section 2, breaking down microservices, scaling complex applications. Okay, so once your monolith is all nicely containerized, it usually becomes a huge bottleneck anyway. To break it apart safely, we lean on something called domain-driven design, or DDD for short. Instead of slicing your code by technical layers, like your UI, your logic, and your data, you group functionality by actual business capabilities, think payments, orders, or notifications. Doing it this way creates these really natural, independent boundaries that can actually scale based on real-world demand. Now, here's the absolute crucial point. With a new architecture, you get new rules. To make microservices really work, you've got to follow these rules of engagement. First off, independent databases per service. Seriously, whatever you do, do not fall into the trap of a shared database, or you completely lose the ability to scale autonomously. You're also going to rely on Kubernetes DNS for automatic service discovery. You'll need to shift to asynchronous messaging, using tools like Kafka or RabbitMQ to untangle those dependencies. And you absolutely must have centralized observability with things like Loki or Prometheus. Otherwise, you're literally just flying blind. Next up is Section 3, Automating with CI/CD, Accelerating Software Delivery. I mean, we've all heard that classic developer excuse, right? Well, it works on my machine. To finally kill that excuse, we move to container-aware delivery pipelines that really embrace this build, ship, run motif. Let's compare mutable tags with immutable digests for a second. If you deploy using a standard tag like latest, well, that tag can be reassigned at any time. It's incredibly risky. But an immutable digest, like a SHA-256 hash, that uniquely identifies one single exact combination of image layers. Deploying with a digest guarantees absolute reproducibility. So the exact artifact that passed in your staging environment is the exact same one hitting production. No surprises. All right, stepping into our run phase, here's Section 4, Deploying to the cloud, build once, deploy everywhere. Taking these bulletproof, immutable containers to a global scale means we're going to lean heavily on the major cloud providers. And the cool thing is, whether you're using AWS with EKS, Azure with AKS, or Google Cloud with GKE, the core operational principle is identical. By using infrastructure as code via CLI tools right inside your CI/CD pipeline, your teams can build an image once and then deploy it identically across any of these environments using consistent Helm charts and manifest. Now we're getting into the deep end, Section 5, Orchestrating at Scale, Operating Kubernetes Reliably. I really want you to let this quote sink in. Kubernetes doesn't magically solve operational challenges, it amplifies both good and bad practices. Seriously, Kubernetes is an absolute powerhouse of a platform, but it is not a magic wand. If you automate a fundamentally broken process, you're just going to break things a whole lot faster. Operating at the scale requires immense discipline. You have to treat the cluster as a self-service platform with really strict, well-defined guardrails. Build for failure. Listen, containers are going to fail, nodes will crash, networks will partition. It's just a fact of life. If you take away absolutely nothing else from this explainer, please let it be this mindset. Kubernetes entirely expects failure to happen, and your systems must expect it too. Resilience simply cannot be an afterthought here. So to actually survive all those inevitable failures, you really need a few production essentials. First, you've got to use GitOps with tools like Argo CD to make sure every single change is declarative, version controlled, and instantly recoverable if things go sideways. You also need golden signals dashboards and Grafana to keep an eye on latency, traffic, and errors. Then you absolutely must define liveness and readiness health probes so Kubernetes actually knows when it needs to step in and help. And lastly, carefully tuned horizontal pod autoscalers. Because frankly, automation without that level of observability, that's just a one-way ticket to complete chaos. And that brings us to our final pattern, Section 6, securing the container, shifting security left. Obviously, security has to wrap around this entire lifecycle we just talked about. Securing a production cluster actually starts all the way back at the very beginning, in the Docker file itself. During the build stage, we scan our images with Trivy to catch any vulnerabilities super early. Then, in the ship stage, we sign those images using cosign to guarantee their integrity. Finally, in the run stage, we're protecting our credentials using external secret managers, and we're dynamically enforcing least privilege with tools like Kyverno. You see, security isn't an add-on, it's woven into literally every single step. I absolutely love this quote from the source author, Gabriel N. Schenker. He says, "Technology alone does not transform organizations. People do. Containers encourage teams to take ownership." And he hits the nail on the head. All these fancy tools we've been talking about, Docker, Kubernetes, CI/CD pipelines, they're really just enablers. Real, lasting improvement comes from disciplined engineering, great collaboration, and a profound cultural shift toward true DevOps, where teams actually own the entire lifecycle of their apps. So, I'm going to leave you with one big question. Are you ready to evolve? The future of software delivery is undeniably declarative. It's automated and it's continuously improving. We've just walked through the patterns, the pitfalls, and the real-world practices that build sustainable, observable, and secure systems. Now it's completely up to your engineering discipline to make that leap. To continue your cloud-native journey, definitely come join the Discord community. It's honestly an amazing place to discuss these containerization patterns and connect with peers who are out there solving the exact same challenges as you. Thank you so much for hanging out with me for this explainer. Keep building with care, automate with intent, and I will catch you in the next one.